Hello बच्चों, let's read this question. Different hydrogen spectral series has different wavelengths. In the given table, column 1 shows the values of energy levels between which electronic transition takes place. Column 2 shows the formula of maximum wavelength of different spectral series, and column 3 shows the formula of minimum wavelength of different spectral series. So students, column 1 is showing the value of energy levels, column 2 is showing lambda max, column 3 is showing lambda minimum. We have to find the wavelengths lambda max and lambda minimum for Balmer series. The key concept of this question: we says that lambda, that is lambda wavelength of a photon emitted by an electron when it transmits from higher energy level to lower energy level is given by, note this equations friends, 1 by lambda equals to r z square 1 upon n1 square minus 1 upon n2 square. Actually happens is electrons upon energy absorbing some energy, they just jumps from their energy level to some higher energy level. Let's say n equals to 3 in this case, from n equals to 1. But electrons in this energy level is unstable. So to gain back stability, it returns the exact energy which it had absorbed and jumps back to the previous energy level. And during this process, it emits a photon of exactly same energy, of difference in energy level of 3 and 1. And these photons wavelength lambda is given by this expression. So students, we are required to find lambda max and lambda mean for Balmer series. What happens in Balmer series is, in Balmer series, electron transmits from higher energy level to energy level second to energy level 2. That is, it jumps from any higher energy level, that may be n equals to 3, n equals to 4. It jumps from higher to n equals to 2. So students, from expression of lambda, we can write the expression of lambda as 1 upon r z square upon 1 upon n1 square minus 1 upon n2 square, where r is Rydberg's constant, z is atomic number, n1 is final energy level, and n2 is initial energy level. Clearly, we will get maximum value of lambda. We will get lambda max when, since this is in denominator, this difference term is in denominator, r and z square is constant. So lambda max depends on the minimum value of this difference, that is 1 upon n1 square minus 1 upon n2 square. So 1 upon n1 square minus 1 upon n2 square, this difference term will be minimum when when n1 equals to 2 and n2 equals to 3. That is, electron jumps from just higher energy level, so that difference will be minimum. And for maximum difference, 1 upon n1 square minus 1 upon n2 square, electron must transmit from infinity to second energy level. Out of these possibilities where electron can jump from 3 to 2, from 4 energy level to second energy level, to fifth energy level to second, to 6 to 2 second, out of 2 to infinity. Out of these energy levels, this will give the difference value minimum, hence lambda. And from infinity to transition of second, the difference value will come maximum, hence we will get minimum lambda. So we can find the lambda max and lambda mean now. Lambda max will be 1 upon r into z square. This difference term will come minimum for n1 equals to 2 square and n2 equals to, sorry, n2 equals n1. This difference must be a minimum, and this will be minimum when transmission takes place from third energy level to second energy level. This is 1 upon 2 square minus 1 upon 3 square. So this is r into z square into, this is 1 upon 4 minus 1 upon 9. This is 1 upon r z square into, this difference is, taking LCM, this will be 36, 9 minus 4. So this will be 36 upon 5 r z square. This is lambda max. The minimum, this difference will be maximum, and this will come when transition takes place from n1 equals to 2 and n2 equals to infinity. That is, electron transmits from infinity to second energy level. This is 1 upon 2 square minus 1 upon infinity square, and this term will be 0. So 1 upon r z square into 1 upon 1 by 4. So this is 4 upon z square, and lambda max we calculated as 36 upon 5 r z square. So students, max was 36 upon 5 r into z square. This is hydrogen, so atomic number is 1. So this is 1 square. So 36 upon 5 r, and lambda mean will be 4 upon r z square, and z is 1 because atomic number of hydrogen is 1. So this is 4 upon r. On seeing the options, we can say that should match with first, and this first should match with the lth option of column 3. So second, first, and L is the correct combination. Second from column first to first in column second, and L from column 3 is the correct combination of this question. I hope आपको ये concept समझ आया students. Thank you.